In this video, I will show you how to use implicit differentiation to accomplish a variety of things. First, we will find the second derivative in terms of x and y. Then I'll show you how to find the equation of the tangent line to the graph at a given point. Then I'll show you how to find the equation of the normal line at a given point. The normal line is perpendicular to the tangent line. And finally, I will show you how to find the points at which the graph has a vertical or horizontal tangent line. Find the second derivative implicitly in terms of x and y. So that means we need to basically find the derivative twice. Since we are taking the derivative with respect to x, and yet in this first term we have a y, we have to treat this as the chain rule. We're going to treat the y as a function inside of a function. So taking the derivative of the outer function, we're going to have 3y squared. But then we're going to multiply by the derivative of this inner function, which is just dy dx. So whenever the variables don't match, you have to use the chain rule. And then the derivative of 4x is just 4. Let's get dy dx by itself by dividing both sides by 3y squared. So we end up with 4 over 3y squared. So we've now taken the derivative once implicitly, and now it's time to do it again. Before we take the derivative again, let's just rewrite this a tiny bit. I took the y squared that was in the denominator and I took it out of the denominator. So now we have y to the negative 2 power. So now let's take the derivative again. Remember, because we are taking the derivative with respect to x, and yet this is a y, we are going to have to use the chain rule. So taking the derivative of the outer function, negative 2 times 4/3 will be negative 8/3. Reducing this power by 1, we have to the negative 3 power. But then we have to multiply by the derivative of the inner function, which will simply be dy dx. On the right-hand side, we need to only have x's and y's because we're solving in terms of x and y. So we can't have this dy dx sitting here. Luckily, we came up with an expression for dy dx several steps ago. Dy dx equals this. So we can substitute that in now and have times 4 over 3y squared. Kabam! Also, to be consistent, I went ahead and dropped the y to the negative 3 power back down to the denominator, so we are ready to multiply straight across. So we end up with negative 32 over 9 y to the 5th power, just adding these exponents. And that is about as easy as those problems get. Find an equation of the tangent line to the graph at the given point. Whenever they ask us to find an equation of a line, we always use point-slope form, which works like this. But this means we need two things. We need a point and we need the slope. One of those things we already have. We have a point because they gave us the point of tangency. That means we only need to find one thing, and that is the slope. However, if you want to find the slope of a curve at a point, you're talking about the derivative. So of course, let's find the derivative. On the left side of the equation, we have a y instead of an x, so we will need to do the chain rule. The derivative of the outer function will be 2y, but then we need to multiply by the derivative of the inner function, which will be dy dx. Looking at the right-hand side, we have this big old quotient, so we're going to have to do the quotient rule. Do you guys remember the quotient rule poem? Low d high, less high d low. Draw the line and down below, the bottom squared will go. When we say low d high, low means just write down the denominator. So here's low, x squared plus 1. And then d high means the derivative of the numerator, but the derivative of x minus 1 is just 1. So there's a low d high less high d low. High means just copy down the numerator the way it is. So x minus 1, that's high. Now d low, the derivative of the denominator will be 2x. So low d high less high d low. Then draw the line, and down below, the bottom squared will go. I am going to go ahead and reverse these two factors to make it easier to see the distributive property that I'm going to perform. So let's do the, let's just get rid of the 1 right here because we never really needed that. So we have x squared plus 1. Now I'm going to distribute this negative 2x to both of these. So I will have negative 2x squared and then plus 2x. We do have like terms here and here. So let's just combine those together. I think also on this step, let's go ahead and divide both sides by 2y. So watch for this 2y to show up in the denominator. So there I've divided both sides by 2y. Combining the x squared minus 2x squared gives me negative x squared, and then plus 2x and plus 1. So that's it. This is the derivative. This will give me the slope of the curve at any point, and the point at which I need to find the slope is the point 2 comma radical 5 over 5. So that means we need to substitute 2 for all the x's, and we need to substitute radical 5 over 5 for the y. Making those substitutions, we have this. Simplifying, negative 2 squared, this is negative 4, plus 4, plus 1. Down in the denominator, I'm going to leave this as 2 times radical 5 over 5 for a moment. But 2 squared is 4, plus 1 is 5. 5 squared is 25. So we have times 25. I'm putting it up high so you can see what's about to happen. On the next step, this 5 will divide into this 25 and make a 5. And in fact, that 5 times 2 will make 10. So expect to see a 10 radical 5 in the denominator. In the numerator, the negative 4 and the positive 4 just cancel each other out. So this is the derivative at the point 2 comma radical 5 over 5, which means this is the slope of the curve at that point. And that's the one thing we needed. So now we know that the slope is 1 over 10 radical 5. You could leave the slope like this for a free response question, but I am going to go ahead and rationalize the denominator because that is probably what they would do for a multiple choice question. So I'm going to multiply the numerator and denominator by radical 5 and see what I get. So in the numerator, I have radical 5. In the denominator, radical 5 times radical 5 is just 5. So this is 10 times 5, which is 50. So this is probably what you would see for the slope on a multiple choice question. So now we're ready to write the equation of the tangent line. Remember, we are doing point slope form, which goes like this. Y minus y, so y minus radical 5 over 5 is equal to the slope, so radical 5 over 50 times x minus x, so x minus 2. So kabam, there you go. Or this is how it would look if you did not rationalize the denominator of the slope. Number 54 is almost the same as the previous problem. We need to find the equation of the tangent line at a given point, actually two different points, all right? Point A and point B. But in addition to that, we're going to find the equation of a normal line, which is a line that is perpendicular at a given point. So that extra step is really easy. So we'll worry about that when the time comes. Let's go ahead and start by finding the derivative. Let's find dy dx. So the derivative of x squared is just 2x. And then we'll have to use the chain rule because this is a y and not an x. So we will do the derivative of the outer function, which is 2y. But then we will multiply by the derivative of the inner function, which will be dy dx. And then the derivative of a constant is 0. Subtracting 2x from both sides, we have 2y times dy dx is equal to negative 2x. And then dividing both sides by 2y, we have dy dx is equal to negative 2x over 2y. And then the 2's cancel out, and we have, I think I'll just put it over here off to the side. We have dy dx is equal to negative x over y. So we can use this to generate the slope at any point. Okay, so the slope of the tangent line at the point 6, 0 can be found using negative x over y, but that's going to equal negative 6 over 0. Of course, this is undefined, which means we're dealing with a vertical tangent line. So what about the equation of this vertical tangent line? A vertical line always has the equation x equals some number. We can tell what the number will be because we have the x value of 6 at the point of tangency. So that means the equation of the vertical tangent line must be x equals 6. So in general, how will we find the slope of the normal line? Remember, the normal line is perpendicular to the tangent line. So a perpendicular line will have a slope that is opposite and reciprocal. So if the slope of the tangent line is negative x over y, then the slope of a normal line, first of all, will be positive something. All right, I'm going to take away the negative sign. That's the opposite part. And then reciprocal means we're going to do y over x. So this expression will be opposite and reciprocal to the expression that we had for the tangent line. So for this particular point, the point 6, 0, this is going to give us 0 over 6, which of course is simply 0. So we didn't really need this expression to find that. We knew that the tangent line was vertical, which meant that a perpendicular line would be horizontal, giving us a slope of 0. So let's write the equation of the normal line. Because we know this is a horizontal line, then it's going to be y equals something. And we can tell what the number is because of the y value. The y value is 0. So the equation of the normal line will be y equals 0. So let's move on and find the equation of the tangent line and normal line at this point right here. Let's start with the slope of the tangent line, which will be the opposite of x over y. So in this case, we will have negative 5 over radical 11. We can write the equation of the tangent line using point-slope form. So we will say y minus y, so y minus radical 11, is equal to the slope, which is negative 5 over radical 11, times x minus x. So x minus 5. So now let's find the slope of the normal line. Again, the slope of a perpendicular line will be opposite and reciprocal. So I'm going to change this to a positive and turn it upside down. So the slope of the normal line will be radical 11 over 5. Now we can write the equation of the normal line using point slope form. So it's just going to be y minus y, so y minus radical 11 is equal to the slope, which is radical 11 over 5, times x minus x, and that's x minus 5. Kabam! Find the points at which the graph of the equation has a vertical or horizontal tangent line. Our strategy will be to find the derivative. Then we will determine the points at which the derivative is undefined. At these points, we have a vertical tangent line. Then we can find the points at which the derivative is equal to 0, and these will be the points where you have a horizontal tangent line. So let's find the derivative. Remember, anytime we are dealing with a term with a y in it, we will have to do the chain rule. So for the first term, we're going to have 8x, and then the derivative of y squared, we will have the 2y, but chain rule, we multiply by dy dx. Moving on, the derivative of negative 8x is simply negative 8. And then the derivative of 4y is 4 dy dx. And then the derivative of a constant is 0. So the 4 is gone. And we have equals 0. Let's put all of the terms with a dy dx on the left side of the equation and move everything else to the right side of the equation. So we will keep the 2y dy dx over here on the left, along with the 4 dy dx. But we will drag the 8x over to the right-hand side of the equation, and that will be negative 8x. And we will add 8 to both sides, so we will have plus 8. Now let's factor out the dy dx as a GCF. So we will put dy dx in front of parentheses, and inside we will have 2y plus 4. And all of that is equal to this. Just for fun, I think I will go ahead and factor out the negative 8 over here. So if I factor out a negative 8, then I'm going to have x minus 1. So now I am ready to divide both sides by 2y plus 4. So I'm going to end up with dy dx is equal to negative 8 times x minus 1 over 2y plus 4. But I am going to go ahead and factor out the 2 in this expression, so that will be 2 times y plus 2. That way I can do this small amount of simplification, and I'm going to get the negative 4. So I will have dy dx is equal to negative 4 times x minus 1 over y plus 2. So this is the derivative. Let's determine where dy dx will equal 0. A fraction will equal 0 when the numerator equals 0. So this implies negative 4 times x minus 1 is equal to 0. But using the zero product property, I can set x minus 1 equal to 0 and get x equals 1. So this is the x value of a point where the slope is equal to 0. I need the y value as well, because they said find the point where we will have a horizontal tangent line. So the y value, we have to go back to the original equation to find the y value. So let's plug x equals 1 in for all of the x's and solve for y. So here I have plugged in 1 for the x's, and let's see what happens. So this will just be 4 times 1. So this will just be 4 plus y squared minus 8 plus 4y plus 4 is equal to 0. Combining like terms, if you notice, we have a 4 and a 4, so that's 8. But then we have a negative 8. So these three cancel each other out. So I'm going to end up with just y squared plus 4y is equal to 0. Let's solve this by factoring. We can factor out a GCF of y, so that leaves y times y plus 4. Using the zero product property, from this first factor, we have y equals 0. And then from the second factor, we have y equals negative 4. So this leads to 2 different ordered pairs. So we have 1 comma 0 from the y value of 1, and we have 1 comma negative 4 because of the y value of 4. So these are the 2 points at which we have a horizontal tangent line. Next, we need to find the points at which we have a vertical tangent line. For a vertical tangent line, we need dy dx to be undefined. A fraction will be undefined when the denominator is equal to 0. So we will have a vertical tangent line when y plus 2 is equal to 0, which means y will equal negative 2. So we need the x value that goes with this y value. So let's go ahead and plug negative 2 in for all of the y values in the original function, and we'll see what we get. So here I have plugged in negative 2 for all the y values in the original function. So next we have 4x squared plus 4 minus 8x minus 8 plus 4 is equal to 0. Combining like terms, we see a positive 4 and a positive 4. That is positive 8. But then we have a negative 8, which means that these 3 terms cancel each other out. So we are left with 4x squared minus 8x is equal to 0. Factoring out the GCF of 4x, we have 4x times x minus 2. Using the zero product property, we will set each factor equal to 0, and we get x equals 0 and x equals positive 2. So remember, we had a y value of negative 2. And now we will pair that y value with these 2 x values to get the points at which we have a vertical tangent line. So we have a vertical tangent line at 0, negative 2 and 2, negative 2.